Hi guys, Assalamualaikum. In this video we are going to proceed with the next subtopic of application, right, in a dot and cross product, which is finding an equation of line in third dimension. Okay, I believe that you guys know that in your previous mathematics subject, or during your school maybe, we have learned on how to find out an equation for a line, right? An equation for a straight line, right? We have y equal to mx plus c. Okay, y equal to mx plus c. This will be the formula of a straight line for the case of 2D, right? This is 2D. We have x and y, and we can figure out the equation of the straight line by using the idea of y equals mx plus c. Okay, however, when it comes to 3D, level like this, right, it's a straight line, but that is being constructed on 3 dimension. We cannot just apply y equals mx plus c to find the equation for this line. Okay, we'll need to apply the idea of parametric equation here. Okay, and we are going to figure out the straight line by comparing it to a vector. Right, let's see how to do that. Right, so the straight line, right, L in 3-dimensional space can be determined uniquely by specifying a point on it. So first we are going to specify one point on that line and then compare it with a vector, any vector that is parallel to it, because we need the direction. So we have this point and we look at any vector available that is parallel to it. When it means when I said it to be parallel, let's refer back to the definition of parallel vector, which is this: two vectors are parallel if they have the same direction and scalar multiples of one another. Okay, so they basically need to be in the same position, right? Same direction, right? It is just that they don't need to be in the same length. Okay, so just like what we discussed just now, right, this vector need to be parallel with the line that contains this point, because we need the direction. Okay, the direction is what matters. We are not talking about the length. Right? They might not be the same, but we need the direction. So based on that notion, right, we come up with this theorem, theorem 3. The line that passes through point A, right, refer to this figure, line that passes through point A and parallel to vector V here, right, which contain A, B, C, has parametric equations of this. So the x will be equal to x1 plus a times t, y equal to y1 plus b times t, and z equal to z1 plus c times t. Right, t here stands for a scalar, meaning a constant, one value, one integer. Okay, so now we are going to see how can they come out with this formula. Okay, so if this line L is the line that passes through A, right, passes through A and is parallel to this vector, okay, we can say that L consists of point A and any point which is denoted as B, which later when we calculate it, we will get vector AB, right? B minus A will give us a vector AB. We still don't know what is the value. This is just a a concept, and that vector later we can say it to be parallel to V because they are going to the same direction. Okay. However, remember they are just parallel, they are not on the same length. So by parallel, we can use the concept of parallel here in the form of algorithm, which is written like this: AB, which is this line, right, or the vector AB, which we get from this line, should be equal to this vector. However, we have t here. Why do we have t here? Because this indicates the scalar. Remember, a parallel vector need to be in the same direction but not the same length. They can be a different length. So t here will represent the differences in their length. However, if let's say their length is the same, this t will be equal to 1, which will give them the same length, right? So AB equal to TB. This is the first algorithm to create this, right? So we are going to say that vector AB equal to T times V, vector V. Okay, so now we expand it to get this, right? Vector AB consists of x minus x1, y minus y1, and z minus z1, right? X minus x1, y minus y1, and z minus z1. This is how they obtain this. And as for TV, t here is constant, so remain like that, times with v, which is consists of a, b, c. If you expand it, you'll get ta, tb, tc. Okay, so from this, okay, we can create this equation. Okay, so now if you try to rearrange it, right, this is what you get: x minus x1 equal to ta. So x component with x component, right? X minus x1 equal to ta, y minus y1 equal to tb, and z minus z1 equal to tc. From this, we can rearrange it to so that the equation will be in the form of x, y, and z. So this is what we get. Right? If we try to change it in the form of metric, this is how it will become. Okay, and this equation can be described in terms of Cartesian equation, and we eliminate the parameter t, or in other words, we are going to just we can describe it in t terms, right? So rearrange it and we'll get this. So rearrange all of this equation in terms of t, right? So meaning t will be on the left hand side, and others will be on the right hand side. So this is what you get. Okay, so this will be the equation, right? Can be represented in this the equation, the parametric equation can be represented in this form or this form. Okay, now let's try to you can look at the example by yourself. Let's look at exercise 3.14. Okay, find parametric equations for the line that passes through the point A and B. Okay, and then at what point does this line intersect with xy plane? Alright, so for this exercise, it is a little bit different from the concept that we have learned before, because previously they say that to find an equation, you'll need to find one point that is on that line and compare it with any parallel vector. Alright, for example, yes, they give you the equation directly as it is. So you can look, you can try to do the example just like what the concept that we have discussed. As for the exercise, it is a little bit different, because they want you to find an equation, the parametric equation of the line that passes through point A, and they provide you with the extra information of another point that on that line, point B. By right, we can look for the vector for vector AB directly for this question. However, there is one missing information, which is we don't have any vector to be compared with, right? So how to deal with this? Right, there's the way for us to calculate this. First, of course, as I said, we have an access to directly calculate the vector. So just calculate that. We have this vector AB. Then still, to find an equation in 3 dimensions, we still need to apply the idea of parallel vector. So the next task will be to find what is the vector that is parallel to it. Okay, now this is the concept of parallel vector, where vector AB is equal to vector V that is being multiplied by any scalar, right? This is also indicate that they are going to the same direction, but might be in a different length, right? So let's input this. Look on the way on how I input this formula, right? So previously we know that AB is equal to this vector, so this has been established. In other words, for V, it should also be in the same direction, meaning this V here should have the same vector, might with a different length, right? This indicate the direction, and this will indicate the length. So we still don't know what is the T here. So this is how you input the vector part. As for this left hand side, right, we'll go back to the idea of finding the vector, finding a parametric equation, which is we only have one available information of point. So just assume that we have only one information, which is information of A, right? So later we are going to subtract B to find this vector. We are going to subtract B to A, right? So it is x minus 2. We know that the x is 3, but for the sake in creating the equation, we'll just assume that we have one information, which is the information of A. So instead of 3 minus 2, we just put x minus 2, and then instead of negative 1 minus 4 here, we just input y minus 4, and of course instead of 1 plus 3, we put z plus 3, right? Just to input a variable. Alright, so equal to this, right? By right, they should be in the same direction, with might be different length depending on what is the value of t later. Okay, and after that, when we have this, we'll just rearrange it in terms of x, y, and z to get the equation, right? And if they want you to represent it in the form of Cartesian equation, then you can rearrange it and represent it in the terms of t. Alright, so this is the equation of x, y, and z. Next, at what point does the line intersect the xy plane? Alright, this question is rather interesting. First, you need to imagine when they say intersecting xy plane, what actually is happening there. Alright, let's look here. Right, you have, where is xy plane, right? The plane that is on x and y, which is this is x, this is y, so this is the plane. So when your line crossing xy plane, it will be on this plane, and it should be the z should be 0, right? So meaning that what I want to say here is that z is equal to 0. So in a situation of z equal to 0, right, we can input this equation equal to 0, and when this is equal to 0, you will be able to obtain t equal to 3 over 4. And now that we have this information, we can solve for x, y, and z. Okay, substitute all of t and solve for the x, y, z to get this point. So to answer it, at what point does they intersect xy plane? This is the point. Alright, thank you.